Hello, everyone. I I'm really happy to be here today. I've spent more time in Germany in the last couple of months than in my entire life. I've put it on my Duolingo list, um, but I'm not very good at languages, so I'll keep it to English. My name's Jordan Appleson. I'm the CEO and founder of Hark. We're an energy analytics and industrial IoT company. We're based in Leeds in the UK. In the last few months, we've been acquired by one of the biggest smart energy technology companies in the world. And today I'm going to talk a little bit about how we basically have worked with different customers on the journey of kind of basically creating a single pane of glass of industrial IoT data and energy data to basically optimize and automate systems, whether it's buildings, production lines, that kind of stuff. If you ask anyone of the members of our team, like why we exist and what we do, we exist to improve the way the world performs. And that's typically improving efficiency, maximizing yield, and reducing waste. So typically that's waste energy and optimizing energy. It's about 80%, 90% of what we do is energy and power. But as we've kind of all heard today, there's lots of different uses for data. So when we collect a lot of data, we can do other things with it, not just performance analysis, fault detection, train models, all sorts of stuff. So we are a software company by, I suppose, trade. And in that case, what we do is simplify the connectivity to assets. It's kind of the unlocker, the connectivity bit, right? So it's almost becoming a commodity, to be quite honest, where you need to be able to connect different systems. So it might be heating, ventilation, air conditioning systems, energy submeters, process automation controllers, and typically that is connected to the cloud via some kind of gateway device. So the protocols that you see in the industry and in the industrial space, not just energy meters, are things like BACnet and Modbus and OPC and MQTT and all of these other different protocols. And fundamentally, we help simplify that with some software. And they're typically, Schneider Electric, Honeywell. I think I saw a Honeywell person in the room, Alan Bradley, Trend, all of these different types of assets. But fundamentally, simplifying the connectivity to that via a software stack. Lots of open source technology these days, lots of proprietary and enterprise grade technology as well. Fundamentally, that is the first step, right? So you need to get the data out of the assets. How do you aggregate all of that and make it really easy to deploy and commission and then scale out? When I talk about commercial and industrial assets, I'm talking about the C&I space. So we work with supermarkets and manufacturers and chemical plants and food processing and so on and so forth. And typically, there's a wide range of assets, right? They're all very much the same stuff underneath the hood. It's all a bunch of microcontrollers and sensors and blah, blah, blah. But fundamentally, it's all data acquisition and then actuation, right? So what does a food retailer have? So we work with Sainsbury's in the UK and a bunch of other supermarkets. What does a chemical plant have? What does a commercial building have? Like I said, it's all very much the same stuff. I suppose I come at this from an energy perspective. So if you walk into like a Walmart, a Sainsbury's, a Netto, depending on the size of the store, you'll have a refrigeration plant, which may be anywhere from a small store at 50 kilowatts to a depot at half a megawatt. You'll have heating, ventilation, and air conditioning, again, 10 to 50 kilowatts of power. Has anyone ever gone to the supermarket and got like a nice croissant, right? And they bake them in-house? Well, usually there's a load of ovens, and it peaks at like 200 kilowatts when those ovens are on, which is actually surprisingly it's a lot of power, right? You think, to make your lovely croissants that are delicious. And then you get into chemical plants, and you've got very similar systems. You've got air compression systems, process heating systems. The commercial buildings are very similar. These are all technically dispatchable assets, right? These can all be optimized in ways for whether it's occupancy or it's what your production line's doing, but most importantly, it can be optimized against things like energy prices or carbon as well. And these are the things that we do. So the key after connectivity, right, and actually getting connectivity to these assets is what we find in the industry, and this has kind of been alluded to today, is that a lot of this data is very much siloed, right? So you might have your MES system, you've got your SCADA systems, you've then got your utility system, that all of these different systems are collecting data. And then in the digital transformation space that we're seeing is people are trying to put all this in the cloud into a data lake or just a general storage account where they can access all this data in one place. But once you've gained connectivity to these assets, as we've seen, to be able to support optimization holistically from an energy perspective as well, all of that data needs to be in one place, like a single pane of glass, effectively. And there are different users, right? So this has also been alluded to today. You have very, I suppose, specific use cases, right? You might have your asset operators that are interested in faults and very specific diagnostic information. You might have your facilities management team that are interested in your building management system, set points, that kind of stuff. Your energy manager is certainly doesn't care about, an inverter's fault code if it's like completely overheated. They just care about how much energy has been generated from a renewable asset, right? The point is that when you have this single pane of glass, it's one system, but fundamentally you have different personas that need to see different things, and you need to be able to give that data in the right format, that information, I suppose, in a very specific way to tailor to that persona. So when we talk about asset and estate health, right, that can broadly be broken down into the things I've already described, right? So you have your protocols that specifically sit on site, on plant. That might be from, DEN, ND meters, whatever. You've then got API access to other systems, like you might have weather data, which can be used to forward forecast solar generation, all of these kinds of things. They come from lots of different sources. We broadly break them down into things like energy and power, internal process values, external factors, and then things like historic work order information or things that are generated by external systems that go alongside maybe an individual asset or a part of the estate. For us, what we try and do initially is anomaly detection, pattern recognition, predictions and forecasting, and then that gets fed into the asset health and estate dashboards. But fundamentally, the output for anyone in terms of trying to simplify the way they get the health information is an overall performance indication, any kind of recommendations around alarms and specific instances of a type of alarm that is increasing or decreasing, basic statistics initially, and then they can power alerts and notifications, right? You can then use that information to inform control strategies, like macro control strategies to support energy, because fundamentally, what you don't want to do is kind of turn off your production line because the energy prices are slightly more, right? Like that would be very bad. But what you can do is you can optimize the building at very small points depending on how your energy prices change. In the UK, we have intraday markets where the energy prices change throughout the day on the spot market. We also have like day-by-day markets, so forward contracts. And these are the kinds of things that we can try and optimize for. And that kind of brings me to the next point, which is sustainability and cost are ever more interlinked. And what I mean by that is in the UK, when you track the forward delivery contract prices for how much a megawatt hour of electricity cost back in 2021, before the crisis, in the UK, it was kind of £53 per megawatt hour, right? By August 2022, the forward delivery contracts were £511 per megawatt hour, right? So that's almost a tenfold increase, right? So when I talk about optimization in those small factors, I'm talking about at a macroscopic level, which we'll talk about in a sec. There's a tenfold increase in less than 2 years of what that's going to do for the cost base. So what type of critical data is required to effectively, I suppose, optimize your sites and optimize, I suppose, for energy and sustainability? Well, the first thing is like real-time utility data. So that's typically electricity, gas, water data. This is required not just for understanding the cost point, but actually there's regulatory requirements across the globe now around how you report sustainability data. And this is actually very difficult to do because, again, it's siloed. It's typically the utilities. If they've got smart meters or even any kind of AMR, then good luck getting that data. Sometimes it's very difficult. You've then got your individual asset level energy data. So when we're dealing with manufacturing sites, we'll deal with things at sub-metering level, so individual assets, groups of assets. In things like the chemical plants that we work with, it's split into things like process heating, it's split into lighting, it's split into certain production like compressed air. So we get a really good granular insight into what parts of the plants are doing what and how they're used. And then obviously you've got environmental data. So external weather factors, our customers are deploying things like weather stations on site, pH monitoring, effluent monitoring, because they're trying to get the whole picture from a sustainability point of view, from electricity to gas to water to how much waste water from things like toilets have been processed, which is not as sexy, but it's required, right? So the examples of those data, the data that is required, the actual, what do we mean by like energy data? So we deal with things like instantaneous power data, so real power. accumulating read, so consumption, and generation, so import and export. And then when we talk about manufacturing or plants, we're talking about things like run hours, units produced, data from the MES system, so you can start to do cumulative summary like regressions around how much energy is being used to produce certain number of parts and different jobs, etc., etc. This can all be fully automated. That then allows you to understand, I suppose, two things. One is generally how much it costs to run production, right, from an energy perspective. But more importantly, you can actually train models to understand that if you make changes to your production, to a specific energy set point that may affect production, you can then track in real time what your system would have done if you hadn't made that change. And then as things are going on, you can actually calculate the delta very, very quickly at 1 minute intervals, which basically means if you've made a mistake within half an hour, you kind of know that actually we've caused our energy to go up or go down, that kind of stuff. And you're not waiting kind of a month because you're waiting for the energy metering data to come from your utility to tell you that you've spent £1 million more, €1 million more in energy. The fault codes and warnings and downtime alerts are quite important. And they're really important because if you're doing dispatch of energy where you're actually tying into the market, right? So you want to trade energy and you want to use some of your assets to get paid for kind of turning things down, which happens in terms of the demand response market. So effectively, there are times of the day where energy is extremely expensive or there are constraints on the grid, so electricity in this case. You can get paid to turn things off, right? But if you've got faults with your assets or things aren't running like according to plan, and you've committed to that I will turn down something or I will turn something up as well, because you can get paid for turning on assets as well, and there's a fault, you kind of need to know that before you commit to kind of delivering that service and then maybe claiming revenue. You can get a bill for that as well. You can actually get fined. And then you've got your internal process values as well. So temperatures, pressures. These can be used, especially in refrigeration, for example, where we're using fridges as batteries, where there's enough inertia in a fridge to be able to kind of turn it off and at really expensive times of the day, right? But fundamentally, for that hour, the inertia in the system, the temperature as it goes up, as is your state of charge, you kind of need to know the temperature of the fridge so you can turn it back on so you don't ruin the food, right? All of these things kind of are completely correlated, and that's why they're critical. So what does a deployment look like from our perspective? Well, we're completely hardware and vendor agnostic. So if you use Dell or Advantech or OnLogic or Cradlepoint or HPE, our software, like most software these days, is designed to run completely vendor agnostic, so you can connect all of your assets from either a read-only or bidirectional control perspective into one gateway device or existing tools that are on site as well. It's relatively straightforward, and there was a point earlier, I think it was made, about kind of testing this out very fast, doing some controlled tests with like one site or one set of assets to demonstrate the point, and then taking stock of that and then rolling it out. That's typically very much the case of what a deployment looks like. So in the case of the UK, right, so this is Sainsbury's. They're one of the biggest supermarkets, if not, I think they're the fourth in the UK. They have thousands of stores, tens of depots, and we monitor all of their, I suppose, individual assets, bakery ovens, fridges, freezers, lighting, solar arrays in real time at 1 minute intervals across those 600 sites. And then as we deployed that, we tied that into the energy markets. So now within 60 seconds of a price change, we make subtle changes to the stores, and behind the scenes, it's saving them literally millions of pounds a year in energy. No human involvement. It's just signals, state changes, and it just happens automatically behind the scenes. To do that accurately and effectively, though, you need a lot of data. Storing that data is quite expensive, as some people have alluded to. We're not storing images, thankfully. That would be not ideal for what we do. But fundamentally, using that data to then train models and do performance analysis at very granular intervals then allows us to forward feed back into algorithms to then optimize the way that the system works. And this can actually be done with chemical processing plants as well. So this is one of our customers. They have 4 big chemical plants across the world. There's 10 different asset classes, so everything from raw water pump stations to, I told you about the weather stations, et cetera, medium voltage, high voltage substations, and that kind of stuff. Now, using one system, that deployment model where you have a mixture of very, I suppose, commoditized gateways, making the connectivity to the sensors really easy, and bringing all that into one place fundamentally has allowed them to optimize cost based on weather patterns, choose how they're going to orchestrate changes to their jobs in the plant because it's a 24/7 site. And this is mostly done in the UK now and rolling out to, like we've got deployments in the States and the Netherlands and here in Germany. The markets, the energy markets are slightly different across the globe, and that's something that you kind of have to take into consideration too. How am I doing for time? 15 minutes. Okay. Just really quickly, I'll touch on where the world is going, where you're combining future of energy and industrial IoT. Monitoring and control we've kind of talked about, but the world is going to move towards a very decentralized architecture from an energy perspective. You've got a lot of renewables coming on to grids. Solar, wind, they're intermittent, right? And you can't really control when a cloud goes over. You can't really control when the wind stops blowing. So you'll see things like energy storage be deployed, right? That requires a site, whether it's a supermarket or a manufacturing plant. If they're going to deploy solar or they're going to deploy an energy storage system, you're going to need very clever technology to forward forecast load profiles and then make tweaks to the way that you store and dispatch energy, because you want to optimize for cost. You want to optimize for self-consumption. You want to use energy when it's cheaper for you to do that. These are all the kinds of things that happen. Most importantly, you'll probably see there's been capacity limits. So, blackouts, there was a whole thing about, in the news around in the UK especially, but I think there was some stuff in Germany around kind of turning things off because of the price and stock. That's where peak shaving comes into play, like having a way of kind of moving the load around during the day, i.e. your peak load of how much energy you're using across a site. It doesn't just net potential revenue opportunity in terms of optimization, it also allows you to effectively move your demand charges around as well. And then you get into the automatic trading on the markets of pricing. And this is where like I said, this is where all of this is going to go, where you're going to have one central energy management system connected to things like SCADAs. It might be pulling data out as part of training models to then better produce set point or changes or suggested changes to operations on a day-by-day basis to then optimize for energy costs, essentially. There is a whole host of use cases within the energy space and tying this into the C&I space. But fundamentally, we as a business, we typically work with, we have a load of control systems that you can basically plug in and start to automate some of this stuff as well. So just a few kind of key takeaways. I'm sorry I speak quite quickly. It's generally the caffeine that I consume. I'll drink a lot of coffee. But the future of energy management and industrial IoT is combined, right? And the reason it has to combine is to optimize for cost and carbon, right? Not cost is great because that's why people invest in it. Carbon is good because we're doing something good for the planet. But most people don't move in that direction unless there's a return of investment. So you have to combine these things. The simplification of all of this, and I wouldn't say it's simple. I would say it's straightforward and complex over complicated, if that makes sense. There are differences, but having all this data in a single place, like a single pane of glass to be able to operate on, whether it's through federated data exchange formats like we talked about today. I say we, the speaker from Porsche, that was really, really cool. The successful implementation of all of this starts with connectivity and visibility and that data going to the rest of the systems, but ultimately they are becoming a commoditized thing. And that's fine, that's good because when you have the data and you can get the visibility, it's the specialisms around how to automate things like energy and set point control in your plants that are going to drive fundamental cost reduction and optimizations. So I think I've done it in exactly 20 minutes, which was my time. I'm happy to take any questions. Otherwise, we can chat at the round table.